Across the vast red deserts of the fourth planet from the Sun, a solitary traveler moves slowly. Its wheels leave tracks on the ancient Martian soil, and its cameras record every detail of this alien world. This rover is humanity's eyes and hands on a planet that has always fascinated us with its mystery. Mars, the red planet, a world that is at once similar to Earth and completely foreign to it. For thousands of years, people have gazed at the reddish point in the night sky and wondered what might lie there beyond millions of kilometers of cosmic emptiness. Today, we know more about Mars than ever before, thanks to dozens of missions, orbiters, and rovers that have become our ambassadors on this distant world. Mars is almost half the size of Earth in diameter. A day here lasts nearly the same as on Earth, 24 hours and 37 minutes. But the similarities end there. The Martian atmosphere is so thin that it makes up barely 1% of Earth's. It consists mainly of carbon dioxide, making the planet unbreathable for humans. Temperatures here seldom rise above zero, even in summer at the equator, and in winter at the poles, they can drop to minus 130 degrees Celsius. The red color of Mars, which captivated ancient observers, is explained by oxidized iron in its soil. Essentially, the entire planet is covered in rust. Long ago, billions of years in the past, Mars was very different. Rivers flowed across its surface, lakes shimmered in the sunlight, and there may even have been a vast ocean in the northern hemisphere. Evidence of this past is everywhere: dried riverbeds, traces of water flows, and mineral deposits that could have formed only in the presence of liquid water. What happened? Why did Mars turn into a cold desert? Scientists believe that the planet lost its magnetic field about 4 billion years ago. Without the protection of a magnetosphere, the solar wind gradually stripped the Martian atmosphere into space. Water evaporated or froze. The climate changed irreversibly. But even in this harsh world, wonders remain. Mars is a planet of giants. Here stands the tallest mountain in the solar system, Olympus Mons, a volcano rising 21 kilometers above the surrounding terrain. That is almost 2.5 times higher than Everest. Nearby lies the Grand Canyon system of Valles Marineris, stretching 4,000 kilometers and reaching depths of 7 kilometers. For comparison, the famous Grand Canyon in Arizona would look like a narrow crack beside it. One of the most important discoveries of recent decades is the detection of vast reserves of ice on Mars, not only in the polar caps, though they are impressive in themselves. The northern polar cap contains so much water ice that if melted, it could cover the entire surface of the planet with a layer of water more than 10 meters deep. But ice is found not only at the poles. Beneath the Martian surface, just a few meters down, lie enormous deposits of frozen water. Rovers and orbiters have detected pure water ice even in equatorial regions. In some places, cliffs and crater walls revealed bright layers of ice exposed directly at the surface, glistening in the distant sunlight. In winter, an incredible phenomenon occurs at the Martian poles. Carbon dioxide from the atmosphere freezes and falls as dry ice, increasing the size of the polar caps. In spring, this ice sublimates back into the atmosphere, creating strange patterns and jets of gas bursting through the surface. These seasonal changes are so vast, they affect the atmospheric pressure of the entire planet. For future colonists, Martian ice will be a source of life. From it, they can extract drinking water, breathable oxygen, and even rocket fuel. This is why the location of the first Martian base will depend heavily on access to water ice. The rovers exploring Mars today are marvels of engineering. Machines like Curiosity and Perseverance carry entire scientific laboratories on board. They can drill rocks, analyze soil chemistry, search for organic molecules, and even produce oxygen from the Martian atmosphere. Every day of their operation brings new data, new discoveries, and new mysteries. One of the main goals of modern missions is the search for signs of life. Did life ever exist on Mars? Could microorganisms still survive in subsurface ice layers or deep caves? These questions captivate scientists around the world. If we find even a single bacterium, it will change our understanding of life in the universe. Mars also experiences dust storms that can envelop the entire planet and last for months. Fine red dust rises into the thin atmosphere and wraps the world in a reddish haze. For rovers, this is a serious challenge. Solar panels get covered in dust, visibility drops to zero, and systems switch to minimal power mode, waiting for the storm to pass. But there are calmer phenomena too. Martian sunsets look nothing like those on Earth. Due to atmospheric conditions, the sun sets in a bluish haze, painting the sky in cool tones. Rovers have captured these alien sunsets, reminding us how diverse the cosmos can be. Today, many countries and private companies are preparing missions to Mars. They talk about building a permanent base, terraforming the planet, and turning Mars into humanity's second home. These are ambitious plans that will require decades of work, extraordinary technology, and immense resources. But isn't this exactly what ancient stargazers dreamed of when they looked at the red point in the sky? Mars is waiting for us. It holds secrets about the past of the solar system, perhaps about the origin of life, and possibly about humanity's future. Every new image, every soil sample, every kilometer traveled by a rover brings us closer to uncovering these mysteries. And who knows, perhaps someone alive today will become the first person to step on the red surface of Mars. Someone who will leave their footprint beside those of our robotic pioneers and begin a new chapter in human history, the chapter of how we became an interplanetary species.